Good morning, ladies and gentlemen. This is our weekend review, the week of September 28th through October 2nd. Monday, we will continue our lesson. Good morning, ladies and gentlemen. This is our weekend review, September 28th through October 2nd. Monday, we will continue our unit on rewriting equations and formulas. Tuesday and Wednesday, we will be solving inequalities. Thursday, we'll transition to solving multi-step inequalities, and we will conclude the week with basic matrix operations. Next week, we will wrap up the unit on equations with basic matrix operations on Monday, a chapter test review on Tuesday, and we will take our first test of the year on Wednesday. Thursday and Friday, we will transition to our new unit on transformations with transformations introduction on Thursday and translations on Friday.
Good morning. Example 1. Solving inequalities with the focus on multiplication and division. So we have -3 is less than 6. So is this statement true? If you don't know, let's look at it on a number line. So -1, -2, -3, 1, 2, 3, 4, 5, 6. So if I were looking at these two values on a number line, if we start at 0, we know that these values move towards positive infinity. These values are moving towards negative infinity. 6 is greater than -3. So this statement would be true. When we're solving inequalities, we worked with yesterday, what we do to one side, we do to the other, no different than solving equations. So what if I were to multiply both sides by -1? So here, negative times the negative is positive. I end up with a +3. Bring down my inequality. +6, -1, -6. Is +3 less than -6? So again, -3, -4, -5, -6. Here we have -6, 0, 1, 2, 3. Here we have +3. But I see that 3 is greater than -6. So this inequality is incorrect. 3 is not less than -6. So if we were to apply what we've just learned, the rule is simple. When we multiply or divide by a negative, we flip the inequality. So we multiply both sides by -1, we ended up with 3 and -6. Our initial inequality said less than, but in order to make the inequality true, we have to flip the inequality because 3 is greater than -6. So let's explore it a little bit further. So -3 times the quantity of p plus 1 is less than or equal to -18. So we look at our steps. The first step asks, can we distribute? -3, and the answer is yes. -3 gets distributed to everything inside. -3 times P is -3P. -3 times 1 is -3. Now I bring down the rest of my values. -18. So now it look, and I say, can I combine like terms? So I have -3P, -3, and -18. There are no like terms. Can I move variables to the left of the inequality? All of my variables are already on the left. Can I undo subtraction? The answer is yes. So now, in order to undo subtraction, I add 3 to both sides. -3 and +3 cancel. -18, +3 becomes -15. I'm left with a -3P, so I bring it down. Next, can I undo multiplication or division? P and 3 are being multiplied. So yes, I can undo multiplication by dividing both sides by negative. -3 over -3 becomes +1, so I'm left with a P. -15 divided by -3 is a +5. But this is where we have one more step. Do I need to flip or change the inequality? In the previous rule, we said if I multiply or divide by a negative, I must flip the inequality. Less than or equal to becomes greater than or equal to. When I graph on the number line, I have +5, and the values that satisfy the inequality are the values that are greater than or equal to +5. So we're going to check. So I'm going to go back to -3P is less than or equal to -15. So it says the solutions for P have to be greater than or equal to 5. So I'm going to go to a value to the left of 5, and I'm going to pick 0. 4, 3, 2, 1, 0. Yep. So when I substitute 0, is 0 less than or equal to -15? No, 0 is greater than or equal to -15. So 0 cannot be a solution. If I were to pick 10, 5, 6, 7, 8, 9, 10, +10, and I substitute 10 for P, -3 times a +10 is -30. Is -30 less than or equal to -15? Yes. So we know that because one of the solutions that is included in my shaded values satisfies the inequality, that I have done it correctly. Again, if I were to go back and take -3P and substitute -5, -3 times, +5 is -15. -15 is not less than, but it is equal to -15. So we do include 5 as a solution. Yes, I needed to flip the inequality. Example 3. Can I distribute? No. There's no parentheses in order to distribute. Can I combine like terms? No. Am I at a point where I can move variables to one side? No. Can I undo addition and subtraction? When I have a fraction, I cannot. Can I undo multiplication or division? Yes. Because I'm dividing both sides by 21, in order to get rid of my fraction, I want to multiply both sides by 21. So positive times the negative is negative 21. 21 over 21 cancels, and I'm left with v minus 2. I'm not done, so I'm going to start back over with my steps. No, I still cannot distribute. No, I cannot combine like terms. Can I move a variable to the left of the inequality? Yes. My v is here. It's positive. I want to subtract v from both sides. So I have negative v minus 21 is greater than negative 2. Can I move? Yep. Can I undo addition or subtraction? Yes. I have a negative 21. To undo subtraction, I add 21. Negative 2 positive 21 is positive 19. I have a negative v. We are not done. We have a negative coefficient. Negative in front of a v is the same thing as a negative 1v. I'm going to rewrite it here as negative 1v is greater than 19. I still have multiplication in front of the variable. In order to remove the multiplication, I divide both sides by negative 1. Negative over a negative becomes positive. I'm left with v. Positive over negative becomes negative 19. Because I divided both sides by a negative, I change my inequality to v is less than negative 19. In your notes yesterday, we learned that when I graph, less than is an open circle. So at negative 19, I have an open circle. The values that are less than negative 19, if you look at the way that the inequality opens, if you draw a line through the inequality, my ray should point in the direction of the inequality when it's done correctly. So again, I'm going to select the value 0, random number. If I go back to the inequality, is 0 less than negative 19? It is not. Is 1 less than negative 19? It is not. Is negative 19 less than negative 19? No. So when I graph, I have an open circle, which means I cannot include negative 19. This is the graph that shows the solution to the inequality. Ladies and gentlemen, things to remember to get started that was posted today. Homework 1.5b, which is due tomorrow. It is in the textbook, which means we use ClassLink to access the assignment. We will have tutoring again next week from 2:30 to 3:30. And I will see you back here tomorrow.